We can measure anything on these. That's where we start normally. We can measure anything. It's driven by the application and what the customer wants to do. So first of all, what is your design? What are the tolerances? What do you need to apply and how does it function? That drives us down the route of selecting which sensors we apply, how we apply them, what data sets you require and what we do with the data afterwards. It's all very well collecting data, but if you can't do anything useful with it, there's no point.
Ollie, when looking at end-to-end eye accuracy metrology solutions, how does the PMM play its part?
So the PMM, precision measuring machine, this comes into its own when we're looking at customers with really high accuracy applications. So the portfolio that this falls under in Telford here is the high accuracy and special geometry solution portfolio. So we apply this to customers who come to us with applications such as gearbox and transmission cases. So on here, with the different sensors, you can see now it's changing, which we're able to change between different contact sensors, optical sensors, roughness sensors, laser solutions, and we can use those all in combination in one measurement run to get the best out of the machine. So if we take the gear on the machine here, we need ultimate accuracy for that. So we can use the fixed head to conform to the ISO standards that we need for approved gear measurement. But we can also pick up the other sensors like the laser to capture surface and topographic data of that gear that we can use for different purposes. Same applies to something like the cylinder head. We've got lots of different compound holes on those cylinder heads. The valves and seats could also be at compound positions. So we might want to change out to the wrist that's just picked up there. So we've got easy access to all those holes in combination with the rotary table. The advantage comes where we have that high accuracy, but the ability to be flexible. If you look at something like a full transmission, we've got the casings, we want the wrist to be flexible. We've got the gears, we need the accuracy. We've got something like all the shaft components, maybe shift forks, all of those things that are all part of the transmission. Previously, people would have needed to buy a gear checker, a form checker, a small CMM, a high accuracy solution. Here, we can combine all of those together in one package without having to recalibrate between different sensors and systems. We can run it all in one go.
So in essence, it's an all-in-one solution.
Yeah, from top down for our high accuracy applications, it's an all-in-one solution for those powertrain, EV, automotive applications.
Now you mentioned EV, is this a growing market for you? Do you get a lot more demand for this type of work?
So we've seen a huge amount of interest in EV work, again, particularly on this machine in gear components. Now we're looking at gears where there's no engine. The noise that gear makes becomes an issue, and it's something we hear from customers that they want to understand what makes the noise. And traditional gear inspection might not give us the information to be able to actually analyse that. That's where we've got the new sensors that come in and different techniques working with different parts of the business like design and engineering, where we can take data and simulate it as well as just evaluate it through the normal metrology route.
You have many solutions on display this week, which I'm learning about all the time. You have a second machine further behind us. Can you explain the differences between the horizontal probe to the vertical probe and why this is configured in a different way?
Yeah. So this machine here is configured to be your absolute point of accuracy in the system. We're looking at final inspection, are the parts absolutely right? If there's something wrong, what's wrong? This is the investigation machine and the foolproof of your process and validation. Over there, we've got a product from the same family. It's still a Leitz machine, but it's a Leitz SIRIO. And that's more focused at the shop floor environment, first of all, and usually has the loading system. We've got a manual loading system on it there, but that could come with an automatic loading system, robot loading, whatever it needs to be. That's focused at the larger throughput environment where you're checking maybe sampled parts, you're sampling 1 in 10, 1 in 20, and you're using that machine to control the process. It can be used outside of that. There's a lot of applications where that's nice in a normal metrology room because, like you say, the arm is horizontal. You've got very easy access to lots of complex parts, so you can stand a cylinder head up on end. We've got the crankshaft on there that if you watch in a minute, you'll see it do some off-axis scanning with the 4th axis on the crank throw. So still very applicable to lots of general everyday solutions, but first and foremost, that's more of a high throughput machine for the shop floor environment where you still need that ultimate accuracy.
Why should people talk to Hexagon?
People should talk to Hexagon because we take these applications and we look at them from the start and understand the function of the parts and why you need to get what you want from it. It's not just about a measurement, it's more about the whole process and what you're going to do with that data at the back end as well. So we are there from the start, through the measurement and manufacturing, all the way to the data aggregation at the end with things like QDAS, which you'll see later on.